My name is Karen Albertsen and I'm a senior psychologist at the Danish National Research Center for Working Environment. And today I'm going to talk to you about the difference between hypothesis testing and hypothesis generation, and how a confusion of these two concepts may lead to false p-values and falsified research reports. As an example, let's say that we want to explore the possibility that people with extrasensory perception exist. First, we want to find a suitable candidate who we can subject to a variety of extrasensory perception tests. Consider the following experiment. An interviewer stands in the corner with a portable computer, which, at a click on a button, will generate a random number between 0 and 999. When a person walks by, he or she is asked whether he wants to participate in the experiment. The interviewer clicks, a random number is generated, and the person is asked to tell the interviewer which number he or she believes it is. This process is continued until we find a person who can answer the question correctly. Let's say that the person number 100, whose name is Florence, is the first one to answer the question correctly. Now we are done with our exploratory study. From the exploratory study we have found out, or we have generated the hypothesis, that Florence is a psychic. At this point we can choose to do a confirmatory study. In the confirmatory study we will test the hypothesis that Florence really is a psychic. However, we can also pretend that the exploratory study was a confirmatory study. In other words, we can pretend that we already knew that Florence was a psychic before she answered the question. If we do so, we can go ahead and publish the paper, and since the chance that a mere guess would provide a correct answer is 1 out of 1,000, we can report a p-value of 0.001, which is generally accepted as quite high. This p-value is of course false. In this example with Florence, the probability of a correct answer is 0.095. This is calculated as 1 minus the probability of 100 consecutive incorrect answers. And this probability is about 100 times higher than the one reported. Can we ever know whether something published as a confirmatory analysis actually is a confirmatory analysis? Well, sometimes we can, if a research protocol exists which predates the data collection, and if the protocol is adhered to, then we can truly know that we're dealing with a confirmatory study. It's a criticism of our profession that we do not publish research protocols before commencing confirmatory studies.